Okay, if anybody's here, you should be able to listen to me. So if you can't hear me, I guess you won't know if there's a problem, but if you can't hear me, I think that you guys can go ahead and, excuse me, you can chat. Yeah, so if you have any questions. Oh, it is just me. I'm talking to myself. Okay. Well, since nobody's here, I guess I'll just do my thing anyway. So today we're just going to be reviewing some stuff from the solutions chapter we did, which is going to be a lot like molarity, molality, will this dissolve, which one of these is more polar, that kind of thing. Just a lot of skills you should have from Chem 1, but it's always good to review. So let me grab my book. Hey, Timothy.
Hi. Yes, hi.
Awesome. Come on in. I'm glad you guys came because if you don't, I have to like live stream this and there's no one listening, but I still have to talk to myself.
Oh, really?
So let's see you guys are here. Can you guys just give me your names and numbers?
Yes.
Thank you. Are any of you guys chem majors? No?
I hate chem.
Hate
I'm
chem?
sorry.
Okay.
Yeah. Are you a chem major?
Yeah, I'm a chem major.
I'm sorry.
I don't care. Bio, psych, engineering, pre-med.
Bio.
Undecided, bio. How about you?
Undecided.
Undecided, okay. So I got a bunch of problems that we can work on today, just like solutions and molarity and just stuff you should know from Chem 1. So I'll work through those, and if you guys have questions, stop me. If you want me to work on other stuff, tell me. That's okay. This is not formal at all. You have to remember these stuff. Okay. Well, like one of the biggest things that you do in chemistry is polarity, especially if you guys are like bio or pre-med or engineering. If you go into organic chem, the biggest thing you have to have down is polarity. So, you guys know what polarity is before I do anything? Polarity.
It's an unequal distribution of charge.
Right. So it's like dipoles, right? Like induced or yeah, that whole thing. So is water polar or non-polar? Polar. Water's super polar. How about do you guys know what like ethane is? Do you guys know what ethane is? Like methane? Okay, I'll try it. How about CH3 and CH3? So two carbons, each with 3 hydrogens bonded together. You guys know is that polar or non-polar?
Oh, non-polar?
Non-polar, right? Because on one hand it's symmetrical, but on the other hand there aren't any polar groups. Like this carbon-carbon, that's a completely non-polar bond. Carbon-hydrogen, that's a pretty non-polar bond. So overall this guy's not polar. So would this dissolve in water or would this dissolve in alcohol? Yeah, it more dissolve in alcohol, but it's kind of a trick question. It still wouldn't even really dissolve in alcohol because an alcohol has the OH group on it, which looks like water. So this portion of it, which is kind of non-polar, would dissolve that, but then the other parts wouldn't. So that's kind of just a skill, being able to look at those and figure out what's going to dissolve more. Okay, so the first problem I'm going to work says, yeah, okay, which of the following of these do you expect to be most water soluble? So we have I'm sorry about my handwriting. It's not going to get better. C6 and C10. my God. Okay. So NH2OH, calcium carbonate, benzene, and C10H8. That's decane. So which one of these would dissolve in water? Do you guys have any idea?
Calcium carbonate.
Calcium carbonate would kind of dissolve in water. Did you take Chem 1 here?
Mm-hmm.
Do you guys, okay. Do you remember there were kind of those solubility rules? Do you remember there was one about carbonates? Carbonates are generally insoluble in water. So like I see what you're thinking about, like the polarity and the distribution, right? Like that's going to be a negative because it's an ionic compound. But carbonates generally are pretty just insoluble in water. But it would dissolve a little bit at least. So which one here would be super polar in water? One of them would dissolve really easily.
The first one?
Yeah, this one. Do you know why?
Because of the OH at the end.
Yeah, what about the OH makes it dissolve easily?
There's a hydrogen bond.
Hydrogen bonding. Yeah, does that ring a bell?
Mm-hmm.
So this is going to be able to like, so if we have a water molecule here, the hydrogen bonding between that hydrogen, that oxygen, or if we have another water here, that's going to pull it apart and make it super soluble. And it's also an ionic compound, so there's going to be a negative here. So it's going to pull it apart. So yeah, and why wouldn't these two dissolve in water? Do you know what those look like? If I write the formula, like, do you know what the structure looks like?
Isn't it like rings?
Okay, yeah, I'll draw the structure too. That might help. This is benzene, and 2, 3, 4, 5, 6, 7, 8, 9, 10. That's decane. So do you guys know why those aren't going to dissolve in water?
Non-polar.
Yeah, they're non-polar. So basically, like dissolves like. So if you have something polar, it's going to dissolve in a polar solvent. If you have something non-polar, it's going to dissolve in a non-polar solvent. If you have something that has a polar and a non-polar end, like if you're a bio major, like lipid bilayers, do you remember that from cell bio?
Yeah.
Yeah, if you have something that's a polar end and something that's a non-polar end, you can have it kind of dissolve in both. So like they have things called emulsifiers. And that's like if you have a giant chemical reactor and you want to mix things that are polar and non-polar, you can put in some amount of some molecule that has polar and non-polar ends, and it'll mix them all together. Like that's how they make milk and things like that, like things that don't want to mix together because milk's just fat and water. Yeah. Okay. So yeah, any questions on that before I go to the next one? I know that's kind of boring, but that's just a skill you got to have for later stuff. Good to go on polarity? Okay.
Did you mix it over?
Okay, the next one is a problem. Okay, yeah. So the next one is that I'm going to draw it's another one of these. I'm going to draw 4 compounds, and you guys are just going to have to figure out, one of them is going to dissolve in water and benzene. So it's going to dissolve in a polar substance and a non-polar substance. And I want you to pick out which one and tell me why. So we're going to have this guy, and we're going to have this guy, and we're going to have this guy, and we're going to have this guy. Okay, so I'll draw the solvents actually. So then the solvents are, sorry, the board's not calibrated. I'll do that after the problem. Sweet, that's benzene. So water's superpolar, benzene's pretty non-polar. One of these is going to dissolve partially in each. I don't know which one that is.
Is it that one?
This one? Mm-hmm. That's hydroxyacetic acid. So what's your reasoning for that? It's okay if you guess.
Well, I just thought like, because it has a hydrogen bond that would dissolve in the water,
Mm-hmm.
and then I don't know, because like there was like a double bond.
Okay, so let me ask you this. Polarity is about like electron density, right? Are double bonds electronically dense? Yeah, actually, because rather than just having 2 electrons here, you have 4 now. So there's double the amount of double the amount of electron density you would have with a normal bond. It's also double bonded to an oxygen, and I don't know if you guys remember, oxygen is pretty electronegative, which means that it can stable. It can stay like this, connected to oxygen. So this is polar here too as well. So overall, this is a pretty polar molecule, which means it'll be dissolved by water, but not benzene. So good try, but it's not that one. So what's your next guess?
That one. The bottom.
This one?
Yeah.
Okay, why?
Because of the hydrogen bond, it would dissolve in the water.
So this part?
And then, would that be non-polar?
And this is non-polar. Yeah, good. So this is going to dissolve in both. That, I don't know what that chemical's called. Do I have it? Salicyl alcohol. Okay. Yeah. And then this one wouldn't, do you guys know why? This probably wouldn't dissolve in water. This would dissolve in benzene.
Wait, is that like in the center? Is that an oxygen?
Oh, no, sorry. I keep forgetting that you guys haven't taken organic. Okay, so fun trivia if you guys do go into take organic is so that you have this ring structure here, right? This is called cyclohexane, which each of these corners is a carbon. And so in here you can have a couple different double bonds. You can have 3, right? You can have these 3 double bonds. But because this is super stable, these can move around and be at any position. Like this bond isn't really here. They're delocalized over the whole molecule. So how we draw that is just with a circle,
Oh, okay.
just to show that. So sorry, that must look really funky. Yeah, and that's not a bond. That's
So then since it's just carbon and this hydrogen, so it wouldn't since it's
Ooh.
non-polar, it would.
This is chlorine.
But doesn't chlorine dissolve in water? So like, wouldn't it be like partially the benzene base and then 2 chlorines? So like, I would think it would be both.
I'm not sure that chlorine dissolves in water, actually. I mean, if you have like HCl, yeah, but
Like sodium chloride. That's what
yeah, but that's a totally ionic molecule, right? You have a sodium, which is a big plus, and the chlorine, which is a big minus, and they're pulled apart. But these are covalent bonds, right? So covalent bonds are a little bit different. Remember, those don't necessarily dissolve in water, and for those, you have to look at how polar the bond is, and then how polar the molecule is. So a carbon-chlorine bond is pretty polar, yeah. But the other thing is that with this whole molecule, it not only needs to break this bond, but because this molecule is stable, it has to be able to pull apart the molecule. Excuse me. So the thing to look at here is like kind of the vector sum. It's a completely symmetrical molecule. And so the vector sum of like the electron dipoles, the dipoles, they're going to cancel out. So this is a pretty nonpolar molecule, so it'll dissolve in benzene. Good to go? Yeah? Okay. Are you guys kind of past this stuff, or you want me to keep doing things like this? After this, it's just problems.
Can you do something? Wait,
Problems?
I was gonna say go past it. Yeah.
Go past it? Okay. Yeah, if I'm doing stuff and you guys like have it totally down in my the next thing. Okay, percent comp. You guys did that, right?
Percent what?
Percent composition.
Oh yeah.
Yeah, okay. I know this is probably Chem 1 review stuff, but it's helpful because once you start getting to like longer problems in the semester, this is the kind of thing that trips you up. Like if like they say like a 75% composition, like it's easy to just mess that up and be like 7.5, and then it messes up your whole problem. So this is good with you, I promise. Okay, so the problem is basically we have a saturated solution of sodium bromide, NaBr, we have sodium bromide, and they're telling us that we're going to have 116 grams of sodium bromide for every 100 grams of water. Does that make sense so far? So basically what they want us to do is they want us to express this in percent count. So that's grams of sodium bromide for every 100 grams of water. So I'll walk you guys through it. It's really not that hard, but I don't want you guys to do this one because I'm sick of my own voice.
All right.
Thank you. So what are you gonna do first?
So percent composition is grams per gram solvent.
Yeah, that's
Or like, is it total?
okay. Well, if it was just grams with the grams of solvent, that's another measurement. You remember, there's something else that's grams over grams of solvent. You guys remember what that is?
Percent mass, right?
Percent comp is percent over the total percentage of everything you have. Because the solvent's just what's floating in, you know. But if you have 116 grams of sodium bromide and 100 grams of water, you know, it's only floating in 100 grams of water, but if you weigh that beaker, how much is it going to weigh?
Whatever is added.
Yeah, it's going to be the total.
So do I convert it to moles and then convert both of them to moles and then see and then divide moles of NaBr over H2O? I'm still getting this wrong.
Well, no, I mean, you're on the right track, but I think you're overthinking it just a little bit. So right now, we're talking about just in terms of mass. It doesn't matter what the mass is, just how much stuff you have, right? That's all mass is. And so in this beaker, how many total grams do we have, excluding like the glass in the air and all that stuff? Just grams of water, sodium bromide. How many total grams do we have? Okay. And so how much of that is sodium bromide?
Do I literally just put this over 216?
Mm-hmm.
Oh well.
That's all you do. So go for it.
So you put.
And then I guess technically there's one more thing you need to do.
Times 100, right?
Yeah. And like, can you eyeball it and tell me like approximately what it is?
50?
Yeah, 50. It's 53.7. Just over half.
Okay.
There you go. Good. And you guys want to work? You'll remember it better if you guys do it.
Sure.
I promise. Plus, it gets really annoying listening to me talk for an hour. I promise you. Last semester when I asked, basically the kids just wanted me to like talk the whole time. It was not good. Oh, here you put the pen down. And if you want to erase everything, you can just like draw a big circle around it and then tap the middle.
Oh, why is it so dry?
I don't know. That's weird. Okay. So the next one is another one of those problems. Number 4. Not number 4, actually. It's number 13. Okay. Actually, we're going to skip this one because it's experimental and you won't like it. Let's go to number 19. An aqueous solution is 6% methanol. So 6%. Do you guys know the formula? Do you guys know what methanol is? Close. That's sucrose or glucose. You can write CH3OH. Right? So it's methane, but instead of a hydrogen, you have an OH group on it. Mm-hmm. Yeah. So this solution is 6% methanol by mass.
Okay.
And they're giving us that the density is 0.988 grams per milliliter. So they want to find out the molarity of the CH3OH. So What is molarity?
Moles over liters.
Mm-hmm. But more specifically, it's moles of
solute over liters of solution, right?
Yeah, good.
Okay.
Do you know where you start?
I think this is a molar mass and then density, right?
Yeah, go for it.
So this would be like 0.06, not grams, right? Would it be grams?
Well, it's out of mass. So what's the SI unit for mass?
Grams.
Great. Yeah, you got it. But can I give you one piece of advice?
Yeah.
You can do 0.06, but then that's saying that it's out of 1, right?
Mm-hmm.
Like 6% is 0.06 out of 1. Or you could do 6 grams out of 100 grams.
Oh, that makes more sense.
Yeah, it's the same. It's just that doing 6 grams out of 100 grams is just a little bit easier. So you have 6 grams of methanol and 100 grams of solution, right?
Yeah.
Yeah, the board's, I didn't calibrate it, sorry.
And then this is all of it, right?
Yeah, you don't always have to write that. It's just,
Okay.
if it helps you. Excuse me. So,
Well, either I think you have to use the molar mass for each, like for both parts, no matter where you start, right? Or not necessarily. Because like if I take this 2 grams, moles, right? So like if I convert this to moles of solute, then I'll have the moles here, and then I can use the molar mass to find the volume, or
yeah, you use the density to find the volume, right?
yeah. Mm-hmm.
So you can do it all in like one long stream, you can break it up into 2. Like you don't have to do 6 grams over 100 and then go through the whole thing.
Mm-hmm.
You can just do 6 grams and get the moles, and then you can just do 100 grams and do the liter. But if you want to do it as one, more power to you.
So this is like 3, 12.
Oh yeah, sorry, I'll just give you that, 3204. You don't need to know that off the top of your head.
This is also mass, right?
Yeah, that's in grams.
And then you just convert, right?
Yeah, what would you convert?
It's milliliters to liters.
Milliliters to liters, good.
Yeah.
If you leave it in milliliters, that's still right. Moles over milliliters is millimoles. But it never asks you for millimoles ever.
So it's 1 10 to the third. Yeah.
Right, do all the units cancel out?
Yeah. So this is this here, 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 here. Nice here. Then we look with moles.
Moles per liter, good. And that comes out to 1.85 moles. There you go. Yeah, real good. I'll give you guys a writing break, and I can ask you kind of like a fun theoretical one.
So fun.
Okay, so basically what we have is, I wrote my answers on one thing, and it's, okay. So you guys know that you can have different percentages of composition, right? Mass percent, volume percent, mole fraction, all the different things. And so those are not exactly going to always be the same. So like the density of water is approximately 1, right? The density of ethanol is going to be approximately 0.8. And so they want to know, based off of that, why will the percent volume of ethanol be larger than the mass percent of ethanol? Does that make sense? You want me to write the numbers up there?
Sure.
Okay. I know it's kind of funky, but it's kind of a cool question. So just a way for me to delete it all at one point. No, that's annoying. Okay, so the density of H2O is, well, is approximately 1 grams per milliliter. The density of ethanol is approximately 0.8 grams per milliliter. So based on that, why does it make sense that in a solution of these two, the mass percent of ethanol is going to be lower than the volume percent?
Because of the density?
Density, right? So like, what does that actually tell you?
Like the density of ethanol is smaller per milliliter,
Mhm.
right? And then like you can tell because it's like grams per milliliter, so you know that its mass will be like smaller as well.
Yeah, so basically if you have 1 milliliter of water, you're going to have 1 gram of water, right? Whereas if you have 1 milliliter of ethanol, you're only going to have 0.8 grams of methanol. So if you have these in like equal parts in a solution, the volume percent of this is going to be like a half, whereas the volume percent of this is, the mass percentage of that's going to be less than a half. So the whole thing, there's a purpose to this. The whole thing to get out of this problem is that this semester when you are doing, when you're doing problems with like a bunch of different things in the same solution, or if you're working on mixtures and things like that, don't forget the densities and all these other different figures that you have to calculate in. Yeah. Okay, more math then. Number 25 is a fun one. Do you guys want me to do this one, or do you want to do this one?
Many of you do it.
You don't have to if you don't want to. Okay. You don't have to use black. You can use whatever. Okay, so this problem, here, I'll write it up here. So there's a chemical called para-dichlorobenzene. That's this guy we saw before. So they want the molality of this in a solution prepared by dissolving 2.6 grams of this. You can write C6H4 Cl2. Yep. So they dissolve 2.65 grams in 50 milliliters of benzene. And they're going to use the density. So D equals 0.879 grams per milliliter. And they want you to find the molality. Do you remember molality?
Is it grams of solute per kilogram of salt?
Oh, I said grams per kilogram earlier, didn't I? Sorry, no, it's moles per kilogram. Sorry, that's my bad. Yeah. So molality is going to be moles per kilogram. And I think it's moles per kilogram of solvent, not solution, right?
Yeah, like moles of solute over kilograms of solution.
Of
Solvent.
Solvent, right? Yeah.
Solvent.
So before we write anything, that's the difference, right? Because molarity is moles of solute per liters of solution, whereas this is going to be moles of solute per kilograms of solvent. Okay. So do you know where we would start?
Okay, so get the moles of solute first.
Mm-hmm.
Is this the density of this?
That's the density of the solution. So you can dissolve 0.879 grams of parachlorodibenzene for every 1 milliliter of benzene.
Oh, okay.
Make sense?
Yeah.
So how are you going to get the moles of parachlorodibenzene? Yeah, I'll just give you mole mass. It's 147.0 grams per mole. Okay, so before you do that, make sure that all your units are going to cancel out. Are these all going to cancel out?
Yeah.
Close. So you're multiplying grams.
Okay.
Yeah. So if you kept going that way, that would give you grams squared over mole. So if you ever have like grams, you want to divide that by grams per mole? Because then it just gives you mole, right? Yeah, that's why. I didn't actually, just write like n subscript 1 because I didn't actually do the math on that. But we know that that's the answer. That's the moles you have. And then so now you need kilograms of solvent, right?
Yeah. So you could use the density.
Mm-hmm.
This would be.
Exactly. So that's going to give you grams, right?
Yeah.
And then you need to do one more thing with it.
Or divided by 1,000.
Divided by 1,000, yeah. I did all the math in one step, so I don't know what all the little parts are, but yeah. If you take your N1 number and divide it by that, you get the molality, which comes out to 0.410, the whole thing. Mm-hmm.
Oh, that over there.
Yeah, that over that, so I can do that, but I did it all in one step, so I don't know what the individual pieces are. But yeah, does that make sense?
Do you want to be a professor?
I'm sorry.
Do you want to be a professor?
Oh, no, I'm pre-med.
Oh, really?
Yeah. Okay. Oh, no.
I have a question. Are you an art tutor?
No, I just do SI. So ARC tutors, they like sit at the table and you guys show up and they're tutors for like anything. I'm just doing SI, so like I'm just a tutor for like 1 course per semester. Time for that. But are you guys all freshmen? Or are you
Yeah.
transfer students? Yeah.
Yep.
If you guys want to get involved with anything like this, the art's a great thing. Like SIing or being an art tutor, it's like good stuff. And you get paid.
Wait, what year are you?
I'm this is my 3rd year, but I'm a senior.
Oh, so like you're graduating early?
Kind of, I'm doing a co-terminal, so
Oh, what?
that, co-terminals, oh, you guys look at co-terminals, they're awesome. Basically, you do 5 years and you get a master's with your bachelor's.
So it's your 3rd year with co-term now?
Yeah, but yeah, exactly, so that's why it's a little.
Are you gonna finish in 5 years or 4 years?
4.5,
Um,
it depends, because like MCAT stuff too, so who knows.
Wait,
But-
do you know what co-terminals are for? Are they major specific? Like only some majors have
yeah, there's
it?
not all majors have it.
Yeah, you don't get to mix and match, but I know like for biology, I'm pretty sure there's a billion of them.
So it's just like a biochem like bachelor's and master's, like the same majors for.
Oh, no, it doesn't have to be the same major. I'm doing my bachelor's in chemistry, my master's in chemical engineering.
Oh.
So it just depends on the department. Like you can do, I know there's one that's like, you said your biology?
Yeah.
Yeah, there's one where you can do master's in biology, you can do master's in biology for like pre-health stuff, you can do master's in biochemistry,
Oh.
master's in like bioinformatics, you can do a ton of things. It's an awesome thing, especially if you are pre-med. That's a cool thing to do too. Okay, just more problems?
I think I'm gonna go because
Yeah, we have
plus
lab.
Okay, good luck.
But thank you so much.
Yeah, no worries.
Thank you, that was so helpful.
The next time I have this is Thursday night, 8 to 9 p.m.
Do you like continue from where you left off or like review like full stuff?
It depends. I mean, if you guys want me to work on something specific and you know you're going to be there, then email me like a day or two before and I'll like, prepare for that. But otherwise, I'm just going to kind of pick stuff every week and do some comments on it.
Sounds good.
Yeah, and if you guys have like sapling troubles or stuff during the week, you can shoot me an email and I'll take a look at it. Did everybody sign it?
Yep. Thank you.
Yeah, take care.
Thank you.
See ya.